Salam and welcome. So today we're going to be working on the question on the screen that says a sample consisting of 2.0 mole of helium is expanded isothermally. So exothermal expansion is what's going on here. So which means the V final is greater than V initial, meaning since an expansion, the final volume is greater than the initial volume. So this happens isothermally, which is constant temperature or the change in temperature is zero at 0 degrees. So, what this is saying is that the entire process of expansion occurs at a fixed temperature of 0 degrees. So, the volume goes from 5.0 dm cubed to 20.0 dm cubed. Calculate the work done by the system when the process occurs against constant external pressure equal to the final pressure. So, the first thing you have to remember is that the formula for work, right, when you're dealing with a constant external pressure question is negative pressure, that is external, okay, times a change in volume. But this particular question has a twist, and the twist is that the external pressure is not given to us, but we are told that it's going to be equal to the final pressure. So, what this is saying is that the external pressure is going to be equal to the final pressure. So, we can rewrite the work done equation as W equals negative P final change in V. So, change in volume. So, that's basically what's going on here. Now, to consistently work on whatever this is, we have to first of all like write out the parameters, right? We're given n equals 2.00 mole, okay? We're given the temperature to be 0 degrees Celsius. We can convert 0 degrees Celsius to Kelvin by just adding whatever this value for in Celsius is to 273. So we have 273.15 plus 0. So the temperature is really just 273.15. And then, of course, we add the Kelvin conversion. Then we write out the fact that the V initial is 5.0 dm cubed. The V final is 20.0 dm cubed. So basically, we're supposed to like solve for this. So the first thing you have to note is since we're going to use the final pressure, we can use the ideal gas equation like we've been doing anytime we have the perfect gas law. So ideal gas equation, we're going to have P V equals nRT. Well, since we're dealing with final pressure and the temperature is constant, the temperature is okay, number of moles is constant, the gas content is constant. The only thing that really changes from our question is that we have an initial volume and a final volume. And our question is telling us to look for the final pressure. So we have PF. Now we have two values for volume. I got the initial volume and the final volume. We're just going to put F here for final volume because we're dealing with the final part of the process, since that's basically what we're supposed to solve for, the final volume. So PV equals nRT. So that would just be the P final is the same thing as nRT divided by V final. So that's 2.00 mole, okay, times 8.3145, which is just simply kilopascal dm cubed, okay, per mole Kelvin. So this is the gas constant we're going to use. The unit is kilopascal dm cubed or kilopascal in liters per mole Kelvin. Of course, times the temperature 273.15 Kelvin. All of that information divided by V final, which is just 20.0 dm cubed. So of course, let's cancel out the information. So cancel out mole, Kelvin, Kelvin, and then dm cubed, dm cubed. So dm cubed, dm cubed. So the P final ends up being, just putting all of this information in our calculator, we're going to end up with 227, okay, 0.111 kilopascal. So basically 227.111 times 10 to the power 3 pascals, but let's just keep it in kilopascal. So basically we found the final pressure. So we have the pressure that we're going to use. Now we're going to have to focus on going, like, don't forget what this question is, right? The formula is, just rewriting it for you, is negative P change in V. Well, we know it's P final. We've gotten what that is. Now we have to deal with change in volume. We know we go from 5.0 dm cubed to 20.0 dm cubed. So that's just saying change in volume equals 20 minus 5 is the same thing as 15.0 dm cubed. So yeah, that's basically how it works. Before we go on, I need to quickly explain something to you guys. You can see that pascals is the same thing as Pascal is just basically a unit for pressure, but Pascal is also equivalent to Newton per meter squared. Don't forget that pressure really is force divided by area. So the unit for force is Newton, the unit for area is meter squared, hence Newton per meter squared. And that is what is equivalent to pascals, right? Because you can see here that we've got dm cubed and we've got pascals. We cannot solve when our parameters or our information is not in the proper units, because we're not going to be able to properly multiply and get the correct answer. So what you're going to do now is we know what this is, right? We know this one right here. We also know this is dm cubed. We're going to go from dm cubed to meter cubed in order for us to work with this and for us to properly succeed. You're going to see the value of all of this at the end of the day. So now, dm cubed to meter cubed, we need the standard information, right? So 10 decimeter is the same thing as 1 meter. Hence, 10 decimeter all cubed is going to be equivalent to 1 meter all cubed. So doing the math, we'll see that 10 times 10 times 10 is just 1000. dm times dm times dn is dm cubed. 1 times 1 is 1. Meter times meter is meter cubed. So what this is telling me is that for every 1 meter cubed, we've got 1000 decimeter cubed. Well, we've seen that the change in V here, right? Change in V is 15.0 dm cubed. And that's what we're trying to go from that to meter cubed. So we can just use dimensional analysis and write 15.0 dm cubed. Okay, so we're trying to go from 15.0 dm cubed to whatever it is in meter cubed times 1000 is at the bottom, dm cubed, and then 1 meter cubed up top. So we cancel the dm cubed, we cancel the dm cubed. And what we end up with is 15 divided by 1000, which is the same thing as saying 1, 2, 3. So that would be 0.015 meter cubed. So now this is what we're going to use when we're solving our question. So going back, we see that work done is equals to negative P external or P final, okay? Change in V. So that would be work done equals negative, what's P final? Would it be 227.11 times 10 to the power 3? 227.111 times 10 to the power 3. Okay, pascals is the same thing as Newton per meter squared. So that would be Newton per meter squared times change in volume, which is simply 0.015 meter cubed. That would be 0.015 meter cubed. Of course, we can cancel this out. So that would be meter squared cubed, remove that. So that would be negative 227.11 times 10 to the power 3 times 0.015 is going to equal negative 3406.66 and then Newton meter. So that would be Newton meter. Please note that Newton meter is the same thing as joules. Okay, because what is really the formula, the fundamental formula for work is just force times distance. So force units is Newton, distance units is meters. So Newton meter is the same thing as joules. So now we go back to the top of the question, right? We see that our question, the smallest sig figs that we're given is 2 sig figs, which is here, right? 5.0 dm cubed. So we have to put this answer, the approximate value, in 2 sig figs. So that would be W work done equals negative 3.4, okay, times 10 raised to the power of 3 using scientific notation, Newton meter, or work done equals negative 3.4 times 10 raised to the power of 3 joules. So this is basically the answer to the question. If you're wondering why the negative is in front of this particular work, is because the work is done by the system. So the expansion process is being done by the system. Hence, what is going to happen is that it's going to be losing energy. So for example, the energy that you have before you maybe clean your room or before you do a task is going to be more than the energy after you do a task. So this negative is showing us that there was energy lost by the system because they did the expansion process, and the value of the energy loss is 3.4 times 10 to the power 3. That's why we have to denote it with negative to show energy loss. If it's energy gain, it's going to be positive. But in this case, the work is done by the system in the expansion process. Hence, we have energy loss, which is why it's denoted in negative, or which is why we have a negative value. I wanted to mention that I'm a personal tutor that helps students succeed and get A's in all their STEM related courses. So if you need any help, make sure you email me at shuhabitutoring@gmail.com. I teach high school, middle school, and college level students, as well as I do private and personal tutoring in STEM related courses. So make sure you email me if you have any questions or need any help or want to book a session. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.